Hello everybody and welcome to another video from the Red Python channel. Today we will discuss the security features of iOS over Android and why iOS or iPhones in general are more secure than Android smartphones. So we'll first start with the reduced attack surface. The attack surface is the code that processes attackers' supplied input. So if Apple has a vulnerability in some code and either the attacker cannot reach the code or Apple doesn't ship the code in the iOS, the attacker cannot actually exploit this. So therefore, a key practice is minimizing the amount of code an attacker can access, especially remotely. So for this purpose, Apple has reduced the attack surface of iOS compared to Mac OS X. Java and Flash are unavailable on iOS devices. As you know, these two applications have a history of security vulnerabilities, and not including them makes it harder for an attacker to find flaws to leverage. Likewise, iOS will not process certain files such as PSD. PSD is handled in Safari, meanwhile it cannot be opened in mobile Safari. Another example can be the handling of Apple's own formats such as .mov, which is the video support. Many MOV files will not play on iOS devices. And finally, even though iOS renders PDF files natively, only some features of the file format are parsed. Let's jump to the stripped down iOS. Beyond just reducing the potential code an attacker might exploit, Apple also stripped down the number of useful applications an attacker might want to use during or after exploitation. The most obvious example is that there is no shell on an iOS device. In a Mac OS X environment or exploits, the main goal is to try to execute a shell code. Because there is no shell code in iOS available, attackers need to think beyond that. iOS separates processes using different users and groups. For example, many of the applications to which the user has direct access to, such as a web browser or a client mail, run under the user mobile. The most important system processes run under the privileged user root. Many other systems or processes run as the users of wireless or MDNS responder, etc. So by using this model, an attacker who gets full control of a process, such as a web browser, will be constrained by the fact that code he is executing will be running as user mobile. Code signing is another important feature of iOS security, and where all binaries and libraries must be signed by a trusted authority such as Apple. So before the kernel allow them to be executed, they should be signed by Apple. Furthermore, only pages in memory that come from a signed source will be executed. So this means applications cannot change their behavior dynamically or try to morph themselves. Data execution prevention, or DEP, is a mechanism where as a processor can distinguish which portion of memory are executable code and which portion is data. So DEP will not allow the execution of data, it will only allow code execution. This is important because when an exploit is trying to take place, they will run a payload which will probably be injected in the data side. There are some workarounds in where attackers use return-oriented programming to bypass this feature, but with ASLR or address space layout randomization, this is not feasible, because in ASLR, this will make it difficult to the attacker by randomizing the location of the objects in memory. So the attacker will not know which is the location of data and which is the location of the code. And last but not least is sandboxing. So sandboxing has two effects. First of all, it limits the damage malware can do to the device, and second, it makes exploitation harder.